Hello, and welcome back to another episode on STEMosphere. Please be sure to like, share, and subscribe for more interesting and fun videos just like these. Now, before we get started, a friendly reminder that if you have any suggestions for any videos that we do here on this channel, feel free to put a comment down below if you have a particular interest or a particular thing or concept that you'd like to go over, and we will definitely take that into consideration for a video that we can do for next time that we meet here. Now, additionally, feel free to comment down below if you have any questions about any concepts, and I will do my best to answer those as soon as possible. Now, without any further ado, let's go ahead and get started. So in today's video, we'll be talking about cross multiplying. Specifically, we are going to be looking into what is cross multiplication and how does it work. So as we see, cross multiplying kind of gets its name from exactly what it is. When we look at cross multiplication, we typically have, take for example, 3 over x is equal to 4 over 5. Now, cross multiplication is something that's very interesting because it can be used for calculating percentages. It can be used for figuring out how things are equivalent, a very common concept used in geometry. And it's something that's very helpful when it comes to understanding how things are equivalent or are potentially equivalent to one another. So, as we have here, whenever we are cross multiplying, we are specifically cross multiplying in a sense that we're multiplying terms across from each other. So by doing that, we are able to gain a sense of what things equal and how they are equivalent. So 3 times 5 is equal to 15. And then x times 4 is equal to 4x. Now, once we arrive at this particular moment and instance, we are going to set 15 and 4x equal to each other. So now we have 15 is equal to 4x. And then after we do this, we simply just do basic algebra to figure out what x is. And x is equal to 15 over 4. And that is how cross multiplication works. So to go back and review, all we are doing is that whenever we have a term, and I'm going to do this as a formulaic process, so we have a over b is equal to c over d. I'm using a, b, c, and d solely because they're chronological variables, a, b, c, d, the alphabet. And all you're doing is multiplying a times d, and you're setting that equal to b times c. So what we did over here, 3 was a, x was b, 4 was c, and 5 was d. And when we did that, we get 15 being the product of a times d, and 4x being the product of b times c. And then after we multiplied those and we had our equation, all we did was simply solve for the variable that we were missing. So that is what cross multiplication is. We're simply cross multiplying, and that helps us figure out our answer. Now, of course, we can do this a different way. We can multiply x on both sides. So take this example right here. We could have 3 is equal to 4 over 5x. And we would still need to isolate this term right here. So we would just do 3 times 5 over 4. And we would get 15 over 4 is equal to x. So we would still get the same answer, but cross multiplication is essentially a quicker way of conducting our steps to where we can figure out the answer quicker, and it's more applicable to certain subjects in math. So with the basis and somewhat foundation of that understanding down, let's take a look on a specific problem this can be used for. And specifically, we're going to review this with geometry. So say I have a triangle, and these triangles are not drawn to scale. One right triangle, and then I have another right triangle. And say this side was 3, this side was 4, and this side was 5. And then for this side, I say that this is 9, this is 15, and this is x. Now, if I wanted to figure out what is x for this triangle, cross multiplication plays a big part in doing this. Now, we can assume that these triangles are congruent solely because they share an angle. As a matter of fact, I don't want to go into proofs just yet, but we'll just say that these triangles are congruent to each other, meaning that they are equal to each other, but they're just scaled differently. So, when trying to figure out a side of a triangle, all we have to do is correlate through proportions. So just as we have a 3 right here and a 9 right here, we would say 9 over 3 is equal to x over 4. So why I did this, it was because we are matching this side to this side, and then we are matching this side to this side. We have to be sure that we are parallel when doing this. So as I have this 9 coming first, right here, and then this 3 going below, that from this triangle, that means from this triangle as well, the x must go on top and the 4 must go at the bottom. So it's very important that with proportions and when doing cross multiplication is that you set it up correctly, and this would be the correct way to do it. So now that we have our setup, 9 over 3 is equal to x over 4, we would cross multiply. So we would do 9 times 4 and 3 times x, and then we would have 9 times 4. This dot, if you didn't know, just means multiplication, and that would give us 36. And then we do 3 times x, that gives us 3x. And then we would simply just do 36, do it on this bottom left right here. 36 is equal to 3x, and we'll divide by 3 on both sides, and that would give us x is equal to 12. And then when we remove our x right over here, and we write 12, we can see that the difference between these two triangles is that it's scaled by 3 from the left to the right, and it's dividing by 3 from right to left. And that is how cross multiplication helps us with math. And this can be seen through geometry, it can be seen through percentages, it can be seen through algebra, it can be used for calculus, it can be used for so many different mathematical concepts, and it's a true and great trick to use. Thank you so much for listening and enjoying this video on cross multiplying. If you have any questions, feel free to drop them down below in the comments section. As always, be sure to like, share, and subscribe. And be sure, if you do have any questions, again, just drop them down in the comments below. I would love to answer them, whether those are big or small questions. Thank you so much for listening, and be sure to tune on to the next video on STEMosphere. Thank you so much for listening. Have a good one.